everybody, I am Snitha Chakraborty and I am here to talk about our project, which is assisting to detect life-threatening arrhythmia using support vector machine. My colleagues Shobita Kunge, Koshvita Reddy and I came up with a device which is used to detect abnormal heart rates when with the input ECG signal. Arrhythmias are basically abnormal heart rates of a patient which can cause cardiac arrest and may lead to death. Sudden cardiac arrest is a major health problem that accounts approximately for 6 million deaths across the Europe and United States. Our device can detect diseases like sinus bradycardia, sinus tachycardia, atrial flutter and ventricular flutter. And the advantage of our project is it's non-invasive, safe, easy to use and very inexpensive.
The main purpose of the software part in our project is to highlight and detect the QRS complex using Pan-Tompkins algorithm. Later, the feature parameters are extracted and the signal is classified using an SVM classifier. So we got the ECG data from MIT BIH database. It's easily available online. So any ECG signal, raw ECG signal, it has like a lot of noise. So this noise has to be eliminated. We have noise like baseline wander, artifacts due to electrode movement, muscle noise, etc. So this noise has to be eliminated for further accuracy of the signal processing. We have various steps to remove the unwanted noise, such as cancellation, which cancels out the overlapping signals, and normalization, it removes the unwanted signals. So now let's get to Pan-Tompkins algorithm. So the main objective of Pan-Tompkins algorithm is to detect the QRS complex and highlight it for further processing. So there are like 4 main steps involved in Pan-Tompkins algorithm, which are filtering, differentiation, integration and squaring. So now let's get to filtering. So here we use low pass filter and high pass filter. As we know, a low pass filter, it attenuates the high frequency signals and it passes the low frequency signals. And in the same way, a high pass filter, it will attenuate the low frequency signals and it will pass the high frequency signals. The step involved is differentiation. In differentiation, it's used to find out the high frequency signals which are associated with the QRS complex. They differentiate the QRS complex from the other ECG waves. So what it does is, it provides a larger gain to the high frequency components arising from the QRS complex. So now let's talk about squaring. It makes the result positive. So it emphasizes on the large difference resulting from the QRS complex. After squaring, we have the final step, integration. So the squared waveform passes through the moving window integrator and it sums up the area under the squared waveform. So after completion of all these 4 steps, our Pan-Tompkins algorithm is complete. So by the end of this, we have a highlighted QRS complex which can be further processed.
The pre-processed ECG signal is divided into non-overlapping segments. For each segment, a set of 11 parameters which are categorized under spectral, temporal and complexity parameters were computed. Finally, a SVM is used to classify the ECG signal into arrhythmic and normal. If it's arrhythmic, an alarm is set on and a message is sent to a mobile phone. If it's normal, only a message is sent to the mobile phone. A detailed description of the hardware is shown in the demo, which is discussed later. Components of the hardware includes a RS-232 USB to serial port. This is the connection which connects the software part, that is our computer, to the hardware setup. So we also have a Zigbee transmitter and a Zigbee receiver, where this is a wireless transmission. Then we have a Arduino microcontroller, a GSM, where the SIM is inserted, and a mobile phone. The overall setup of the hardware looks like this.
We have a demo of our project. So we are running the code. So it opens up the data. We are selecting a data, ECG data. So we are selecting an ECG data and we are running it. It will take a while. So yeah, it's abnormal heartbeat detected and that's why the alarm is on. And we'll also get a text message through the GSM. Text message will take a moment. Yes, we got the text message saying it's an abnormal heartbeat. So we'll set the alarm off now. We'll check for the normal heartbeat. So that's the waveform. Now we'll check out for normal heartbeat. So we'll run the program and select a data. So we selected an ECG data and we're running it. It says it's a normal heartbeat in the dialog box, and that's why there's no alarm activated. But we are getting a message through GSM. So basically, if it's a normal heartbeat, the alarm is not on. We're just getting a text message through the GSM.